Okay, so for our next examples, all we're going to do is decide what movements the graph does. I'm going to let you actually do those movements for the graph in your college algebra class. I just want to, again, get you comfortable with it. So we're going to do a couple different things. We're going to name the common function. We're going to decide if it has a horizontal shift, if it has a stretch or compress, if it reflects it over the x-axis, reflects it over the y-axis, or has a vertical shift. If it doesn't have that, we're just going to say no. If it does, we're going to say what direction and how much it goes. So if we look at this first graph, that means if I get rid of this plus 6 to do my common function, I notice that I'm left with x cubed. So my common function here would be x cubed. Now, since there is a plus 6 directly added onto my x, this is a horizontal shift. Since it's a positive 6, that means it's going to go to the left 6. Now for stretch or compress, remember that's a number out in front. I don't have a number out in front, so I don't have a stretch or compress. Remember that x reflection is if there's a negative out here in front, which I also do not have, so that would be a none. And the y reflection would be if my x inside my parentheses was negative, which it is not, so that is also going to be a none. And last, a vertical shift would be if there was something added or subtracting on here at the outside, which there is not, so that would be a none as well. So the only movement that this graph made was that it went to the left 6 units. Alright, so let's talk about the second one here. Again, if I start covering up pieces and I have to cover up the plus 3 and the minus 1 and that negative 2, so I am left with the square root of x. So there's my common or parent function. Alright, so we want a horizontal shift. Remember, horizontal shift is an addition or subtraction attached to your x. So since there is a plus 3 added onto that x, that is going to move it to the left 3. Okay, so let's talk about stretch or compress. There is a number sitting out in front of this, so we do need to stretch or compress. It is a positive 2, so that is bigger than 1. Remember, bigger than 1 is stretching, so we're going to stretch by 2 units. So now we're talking about a reflection over the x-axis. Since that is a negative 2, we're going to say yes, it does reflect over my x-axis. What about a reflection over the y? So since my x is a positive in there, that would be a no on that one. And a vertical shift, remember that's added or subtracted on here to the end, so that is a negative 1, so that is going to go down 1. Alright, so let's look at the next one. Again, let's look at our common function. So we're going to cover up anything added, subtracted, or multiplied. So I'm going to cover up this negative 4 and the 3, as well as this negative 4 inside that, not parentheses, absolute values, because that is our common function. So our common function is the absolute value of x. We do indeed have a horizontal shift. We've got this negative 4 inside the parentheses. That means that is going to move it to the right 4. Remember, when it's a horizontal, it's always opposite of what you think it should be. So since it's negative, we think it should go left, but it actually goes to the right. Now we're going to do our stretch or compress. That is if there's a number multiplied out here directly in front of our function. That's that 3. So since it is greater than 1, that is a stretch of 3. We do not have a reflection over the x-axis since that is a positive 3, so this is going to be no. And we do not have a reflection over our y-axis since that x is also positive, so this is no. We do, however, have a vertical shift. Now our vertical shift is in a little bit of a different spot. It's up here in the front at the negative 4, where normally we would see it back here on the back end of this. So they've just written it out of order, and that's okay. If that gets confusing for you, we could have started the problem off by saying, hey, let's rewrite this so that everything is in its spot, and now all of a sudden it's very easy to see our vertical shift. So if that gets confusing to you, go ahead and rewrite it so it looks like this. So we would have a vertical shift and it would be going down since it is negative, and it would be going down 4 units. Alright, so let's look at our fifth one here. I'm going to cover up the plus 5 inside that parentheses as well as the negative 4 over here. and I am left with 1 over x squared. It was kind of hard to do, it was really small. That's our rational squared function. So does it have a horizontal shift? Hopefully you're saying yes, because we got that plus 5 on the inside with the x. So it is going to go to the left 5. It does not have a stretch to compress, so this is none. However, it is reflecting over the x-axis since you have a negative out here in front of the function. So this is a yes for the reflection. It is a no for the y reflection. So we're only reflecting over the x-axis. And then again, we have this minus 4, so we are going to be shifting our graph down 4 units. Okay, so we got one more example to do here for this one. Saving the best for last, right? So on this one, when you have something like this where you have this divided by 4, I do like to go ahead and rewrite this as negative 1 over 4 x squared minus 2. I think it makes it easier to pick out all the values. Again, we would want to cover up anything multiplied or added or subtracted. So we would cover up the 1/4 and the negative 2 to get our common function, which is going to be x squared. Now on this one, we do not have a horizontal shift. That negative 2 is actually our vertical shift because he's outside of the x squared. It would have to be inside with the x for it to be a horizontal. So this would be that we have none. We do have a stretch or compress because we do have a number sitting out in front of our x squared. That is 1/4. Since it is smaller than 1, this is a compress of 1/4. And we do have a reflection over our x-axis since it is a negative 1/4. We do not have a reflection over our y-axis. And we do have a shift in our vertical. That's that minus 2. So we're going to go down 2.